initial what? Initial pressure. From one side to mass OS S1. So the same length, the S is here. And when you change the water line, another S also is here. So when you pick here, from here to here is 1x. And from here to here is the x. So you realize that there has been what? A triangle here. And there has also been what? Another what? Triangle being what? Being from here. And it has changed. This very thing. We are trying to integrate this very time. So on the order or a shift in the center of gravity of the vessel from J what to J1. And we have also we said some time ago that when there is change in the or there is movement of masses, the center of gravity what will change when there is movement of what masses. So we also said that when you have one mass and you add mass, the center of gravity moves towards that mass. And then we move mass. Center of gravity try to move away and all that. So we said that when you move that, the center of gravity of the mass from what? J0 to J1. So if you have the mass in it, so this is, so from there, we also did how you call it initial stability. That was it. We also did initial stability, and we said that we have the metacentric height. We also have how we call it center of gravity, and we also have, since the center of gravity has moved, it will move from J to J1, and we also saw why we have what GZ, and we said that is the writing arm. So we said that. So immediately this vessel inclined, there's formation what pop that. Since this vessel has inclined, it means that there will be what some angle that will form because the vessel will incline in a certain angle. All right. So then it means that we are having certain angle here. So then we have to form the angle. There is how do you call it a proof. Okay, there is a proof how to prove that J1 is equal to the density of liquid and second movement of area of liquid over the surface times tan theta all over what the displacement. And because of time and other stuff, I will urge all of you to, if you have width, there is a book called width. You get that width book. There is the proof, but the formula of changing from the center of gravity from one point to the other, that is the density of free surface times the second moment of area of liquid surface times tan theta all over what mass displacement. So under the effect of free liquid on stability, if you want to change from one mass to the other, then we have the the density of the free surface of free liquid, that is the liquid in the tank, times the second moment of area of the liquid within the surface. So this is the liquid. The forces within the liquid that is actually causing the vessel to also to incline. Times what theta, the angle, the formation of what the angle that will form all over what the mass displacement. All right, let's go on. So we say that since displacement is now effectively acting through J, then the metacentric height can be said to have been reduced by the amount of J2, J empty, where J is equal to the center of gravity to the center of gravity 1 all over tan theta. You already know that J1 is this, so you put that one there. Tan what? Tan theta. So this very tan theta, cancel that, and you have the density of the free surface liquid, second movement of inertia of the liquid all over what how do you call it the density what the mass displacement. Yeah, so then we can say that the reduction is therefore to add the free what surface what effect. So then this is what the formula for free surface what effect. The FSE, the F is free, the S is surface, and the E is what? The E is effect. And the formula is the density of free liquid times the second moment of area of what? Of liquid. That becomes what? The free what? Surface what? Effect. Now let's see. It must be stated that the effect of free surface is neither dependent on the height of liquid in the tank nor the position of the tank within the ship. It must be stated that the effect of free surface is neither dependent on the height of liquid in the tank nor the position of the tank within the ship. What do you understand by this statement? Someone should tell me what you understand by the statement there. It must be stated that the effect of free surface is neither dependent on the height of liquid in the tank nor the position of the tank within the vessel. Someone should explain to me the meaning of the statement.
Yeah, sir. My understanding.
Okay, one at a time. And to your understanding, the gentleman, the one talking, I'm hearing.
Okay, sir. Irrespective of the height of the liquid in the tank or the position, the effect encountered is always the same all over the ship.
All right. Okay, who again? Who again?
It means that when the height of the liquid in the tank, the position, the free surface effect is the same.
All right. So, yes, all what we are trying to say that more or less maybe when you take your pure water of the bottle, will still happen. It's not like something like, okay, you have something small, so this one there is negligible. No. Okay, so we are saying that it must be stated that the effect of free surface is not dependent on the height of liquid in the tank, nor the position of the tank within the ship. So you cannot tell me that okay, the tank is at the forward end. So because of the tank is at the forward end, free surface effect will not take place. Or maybe the tank is at the aft, and since it's at the aft, the free surface will be massive there. No. It means that wherever your tank is located, it will still have the free surface, no matter the height, it will still have the effect. All right. So let's see. For a rectangular tank of length and breadth, so if you're having a tank being rectangle, okay, if you have a tank being rectangle, some of the tanks in the ship are not rectangle. Some are. Some of the ship, some part is inclined, okay, and we have some tanks there. So not all the ships, okay, not all the tanks we have on board are rectangle. So in case if you go and find how do you call it, a rectangle, how do you call it, a tank within it, then this is how you can use. This is the formula to use for the free surface effect. Now the second moment of inertia, the second movement of area of the liquid surface, which was the I subscript CL, a second movement of area of liquid surface. Here, we have the density of the liquid times the length times the breadth what cube all over 12 mass displacement. So then this becomes what? This becomes the formula for when you are calculating for a tank of length. So a question could be asked that maybe for a rectangular tank of length and breadth this, it has that, then you have to know that you have to use this formula. But if it states that maybe a tank of, it was not specific, it might even come that you may not be given length and breadth. Then you have to know exactly what you want to do. Then you say, note, the effect of free surface is neither dependent on the height of liquid in the tank nor the position of the tank within the ship. The same thing applies to when you are having how do you call it, a free surface or half liquid in the tank. All right, let's go to this introducing transverse partitioning tanks. Some of the tanks have partitioning. Maybe you have one tank that you have partitioned it in a certain way. I think when you do systems and all that, they will tell some of the tanks why they partition some of them and all that. So if you're having tank like this, and there's a partition, they have partitioning the same tank, but they have done some partitioning. When one transfer partition is introduced, then it means that each and every tank needs to have its own free surface effect. So you have to calculate for the free surface effect on this, calculate the free surface on it. That is if there are two tanks. So this becomes the formula for it. So we're having EIB cube all over 12 pi. So you calculate for this, then it goes to this. Now, when two transfer partitions are introduced, when you also introduce another partitioning, then you have to use this formula or this way to calculate for it. So it means that each and every partitioning needs to be calculated. Then you add all of them. So introducing transverse partitioning in a tank will not change the effect of free surface. The same thing. Though you have partitioning your tank, it doesn't mean that the free surface effect has been changed. All right. So if you go to longitudinal partition in tanks, so that one was transverse. Okay, the transverse way. If you go to the same longitudinal partitioning, so when one longitudinal partition is introduced, then you realize that here the formula has changed. When two longitudinal partitions are also introduced, then you can go in for. Therefore, when longitudinal partitioning are introduced, then different numbers, then this is how you can work it. Whenever a number of longitudinal partitions n are introduced into a tank, the free surface effect reduces by an amount equal to the reciprocal. So in here, if you introduce longitudinal partition, then we can say that the free surface is reduced by an amount equal to the reciprocal. It means that whenever you introduce longitudinal partition, like straight like this, then it means that with this one, you will be able to minimize free surface effect. All right, let's try and solve this example and see. By saying that a ship of 6,000 tons, yes.
And some students aren't able to join the class.
Some students are not unable to join.
Yes. It says the call has reached the maximum number of participants.
Oh, really? So,
yes.
But is it the first time we are encountering this, or always they do encounter?
I think that's the first time.
This is the first time?
Yes.
This one, I have no control, right? I have no control over the number of students to use the platform. But can you share your screen today? I think that thing is possible. Or
I don't know.
yes, some people used to do that, but I don't know. Maybe your end there, I don't know how to resolve that because here. Let me check something. Please, all of you hold on, I'm coming. Action. Hello. I'm coming. Hello. Are they using RMU? Are they using RMU email account?
Yeah.
Okay, wait on. I think some of you are. Hello. Yes. All right. Hello. Well, I don't know what is happening, but I learned maybe if you have not paid your fees up to now, something you cannot have access to some of the RMU platforms. I think I was yet informed that if you have not paid your money and all that, you cannot. Maybe if you have not paid or something, you cannot join. But then you guys should find some ways. But I can see some people are chatting and said, before join through classroom. Well, I think maybe that will be the solution. But I have no control here. I have no control about the number. So let's solve this question. A ship of 6,000 ton displacement has its center of gravity 5.9 meters above the keel and the transverse metacenter 6.8 meters above the keel. A rectangular double bottom tank, which is 10.5 meter long, 12 meter wide, and 1.2 meter deep, is now half filled with seawater of density. 1,025 kilogram per meter cube. Calculate the metacentric height in this condition. So you've seen the question. They said calculate the metacentric height in this condition. So if we have not solved this question here, and you go and meet it somewhere, you will say that you have not been taught, or you cannot solve. Meanwhile, we have done stability, initial stability. So anytime they are interlinked, okay, they are interlinked. So far as you know initial stability, and now you are seeing metacentric height and that, you have to draw it. You have to broaden up and go there, pick some formulas, and come and use it. Okay, pick some formulas and come and use them. All right. So, you see, initially, we have GMT. JM subscript T. And GMT can be equal to, here we have transverse metacenter. And transverse metacenter is what? What is the meaning of transverse? What abbreviation do you use for transverse metacenter? Who can tell me? You said
M subscript C.
M subscript C. Hey, are you sure? Transverse metacenter. Is that
KNT.
MT.
K what?
MT.
Yes. So GMT is equal to KMT minus what? What do you
The G that TMC. KG.
That is what? KG.
KG.
Okay. KMT is equal to what? When we were doing initial stability, KMT was equal to it.
KB plus GMT.
Was equal to what?
KG plus G.
All right. We said that the KMT was equal to KB plus what? BMT is equal to GMT plus what?
GMT plus KG.
Yes. All right. So we now want GMT. Is that not it? We wanted what? GMT. So now from that formula, okay, since we have, how do you call it? KMT, and we also have, how do you call it? KG, okay, we can do the substitution, and we can also do what? Change of subject to get GMT is equal to what? The KMT minus what? G what? KG. So that is what we did. Okay, the GMT was equal to the 6.8, which one? That one was the transverse of metacenter, the 6.8 minus the center of what? Gravity. The center of gravity has already been what? Has already been used. This is 5.9. So this will help us to get what? G subscript what? MT what? GM subscript what? T. So we have that one to what? 0.9 meters. All right. All I'm saying is yes.
So please, some of our colleagues can't join because the maximum number of participants have reached. Can something be done about that?
The number of that one I have no control. Right? So I'm surprised you are encountering the problem now because all this while I've never heard you guys complain about that. So I don't know. But this, so it means that you guys have not been 100 over in the class before.
I think so.
Then why are all of them coming to the class now? Or is it because they thought it's examination, so they are all now coming to class? All right.
I don't think so.
You don't think so?
Yes.
Actually, some were still not allowed to join because they've not paid their fee. So I think that would be the problem.
All right. So they have paid now.
Yeah, I think so.
All right. Well, this one I cannot do. I have no control over. So I think maybe when you finish, then you go and you how do you call it? You also teach them, okay? Because I have no control over this. If it's 100, then it means that how do you call it? Some people will not have access to it because I have no control. If we have encountered this before, then I would have prompted them that the class is more than that. But today that we are almost getting to the end of the semester. I don't think if I go and report this, it will still be well done. So, and today also we are having the class. So I don't know. This is challenge. This is a challenge for us. So, because even this very PowerPoint, I should have maybe be presenting these things so that some of the things you might see them, but I just have to say them so that you can write. So just tell them that it's unfortunate that these things are happening, but maybe as time goes on, I'll let them also be aware of the situation. Okay, I'll
Okay,
let
sir.
them be aware of the situation. Maybe how we can resolve that issue. Then it means that all the classes you guys have been going, you don't usually get to the 100.
Yes, sir.
So a class of
Sir, please, can you record it?
what? What?
The lectures as you are presenting.
Let me see. I'm even almost done.
Hallelujah. Amen. God is so wonderful. We are come to sing to glorify the Lord. In Him I pray.
Sir, please.
All right, it's okay. Let's go on.
Okay.
Yeah.
Like I was making a recorded version of the class available after the class for them to access before, right from the start.
Okay.
When someone leave the group, let me know it so I can join.
Oh, thank you. I guess you're sacrificing yourself for me. Oh, but you should have told me. You should have told me where to leave the group now, so that I'm ready to join too. Oh, me too. I can't still join also.
They have added some mass. So all what you wanted to know is to know exactly the volume of what the volume of the liquid that has been added to this very thing, because a rectangular box tank of which wide is deep now half filled with seawater of density this. So we want to calculate the volume of the seawater that was added. So here, that's why we have the mass what added. So we have the 10.5, which was what, which was the 10.5 times 12, which was what the wideness. So times the 0.6, and the 0.6 is deep. That is the depth of the liquid that was filled was 0.6. So we calculate that. Okay, we calculate that times the 1.025. That is the density. We have changed this one from kilogram to what? To ton. We have changed that one from kilogram to what? To ton. That's why we are having 1.0225. So when you multiply, or you get 77.49 ton. That is the added mass. Now let's come here. Shift in center of gravity due to mass added, because the tank was filled. Okay, the rectangular was filled halfway. So it means that a mass has been added, and we also talked about this. That mass added was the mass times the distance all over the displacement. I hope we talked about that some time ago. The mass added times what? Times the distance all over the displacement that was given. All right. So if this is the mass added, because this one was the volume of the liquid that was added, and it was added halfway. So we can, if it's added halfway, then it means that the depth here, that is why we have the 0.3. So the depth here will also take its own height. So we have that. So you multiply them, you add the mass here, that is the displacement, time plus the mass what? The mass added. Because this was the mass that was added. And this one was the what? A shape of this. So this is the initial displacement of the ship. And now when you add mass to it, it's more or less this vessel will go down and a draft what? A draft will change. So now you can have your changing. All right. Now let's go to how to calculate for what? How to calculate for free surface what? Effect. All right. So
This why was the
is
0.6
that
subtracted from the 5.9? Then why was the 0.3 subtracted from the 5.9?
the 0 point?
The 0.3 subtracted from the
You see that
5.9.
this very one also has its own center of gravity. You see, the whole vessel was having a center of gravity to be 5.9. Okay, the whole vessel has its own center of gravity to be 5.9. And we are saying that above the keel and metacentric height was this. So this metacentric height, okay, also has what? 0.9. Okay, so we presume that if this is the initial metacentric height, okay, then half of this, then we can have what? Our center of what? Gravity of what? Of this liquid. So we just divided this one over because this very thing also may have what? Its own, is coming up with its own center of what? Center of gravity. So now we have the center of gravity of what? Of the liquid. And we also have the ship's own what? Center of what? Gravity. So if you have that, then when you subtract this one from this one, you will be able to get the whole center of what? The whole center of gravity of what? Of the ship.
Half of. You get half of
Half of this GMT.
So
half of 0.9 is 0.9.
0. Point what?
0.45.
It's 0.45 rather.
Yes, sir.
Yeah,
I'll go
0.5,
follow.
not 0.3.
All right. Don't worry, I will work on this thing again, and with the next time we meet, I'll rectify it. Okay, because I think there is some issue here, but I'll work on it again and let you have that. Okay.
Okay, sir.
All right. I'm coming. Wait. No. I'm coming. Okay. I'm coming. You see, we have the wide here. That is the depth from here to here was 1.2. Is that not it? It was 1.2, right? All right. And we filled it halfway. So the 1.2, 0.6 plus 0.6 will give us what? 1.2. Right? All right. Okay. We have the 0.6. So it was filled halfway. Okay. So we have the 0.6 and the 0.6. So it was within this very, how they call it, this very water, okay, this very section that we have its center of what? Its center of gravity. So now the halfway, if you also divide this very thing half, then you are going to get what? The 0. What? The 0.3. Yes, I think it's the way around rather. So is this one rather because the GMT was from here to this place to this very one. So here you cannot divide this one, but it's here. So now we have the depth from here to here to be 1.6, and we divided this one into what? Into 2 because we said it was filled what? Halfway. We presume that from this very halfway, we are presuming that the center of gravity will be at the middle. So if it will be at the middle, then we can subtract this center of gravity from the main what? Main center of gravity. Then we can know that okay, from here to here ought to be what? Ought to be our center of what? Our center of what? Gravity. So that is how come we are having the 0.3. All right. So we have the free surface what? Effect. It's equal to J1, J2. And we said that the free surface effect was what? The density of the fluid times the second moment of what? Second moment of inertia all over what? All over the displacement, the mass displacement. So we have the density 1.025, okay, times, and we also said that if it's a boxed, if it's a box shaped, if it's a box shaped, then we will have the LB cube all over what? All over 12. So the L, the length being 10.5 times the 12, which is the breadth, the wideness, cube all over what? All over the 12 over the what? The mass what? The mass displacement. So please, when you get the note, try this is how we call it. You have to change this. The I here. The I here should be LB cube all over what? All over 12 here. So when you get it, please know that the 12 cube is here, and this over this 12 should also what? Come here. So then when you get this, then you can resolve what? You can resolve this. Then you will get the 0.25. Sometimes we are typing these things and we make some mistakes. So please, when you get it, know that the formula that we have solved here, this one, this is what we are using. For rectangular tank of length and breadth, this is the formula we are using. We already know the length, we already know the breadth, the 12 is already, and the mass what? Displacement. So you put the mass what? The mass displacement there. Then you can what? Therefore, final metacentric what? Height. Okay, so the final metacentric height, we have the GMT is equal to GMT plus JJ minus what? J1, J2. We already know GMT, all right? We already also know JJ1, and we already know this. So you subtract it, then you are having 0.724 meters. So this is how trickish some of the questions will be like. Okay, so now that you know initial stability, now that you know how do you call it, movement masses, when you move mass from here to here, this will be the formulas. Make sure that you have all these formulas, because some of the questions you will apply added mass formulas. Some of the questions you will apply a shifting of masses formulas to aid you to solve the question. Some of them too, we are going to apply initial stability formulas, which will help you to calculate. So you are not going to get verbatim of everything that you have been taught. So these questions like this, it will come in a different what? In a different way that you can use another formula to what? To solve for. So basically, that is how naval architecture is. And this is just the beginning of the naval what? Architecture. As time goes on, we are left with, I think, 3 more to go. So if you don't understand this one, then it will be very difficult for you to progress. So I'll urge all of you to go and get some books and read. Read naval architecture is the ship masters and mates. They are all there. Go maybe naval architecture, and we have ship theories. These are all books that will help you to understand all the naval architecture we have done so far. When you go and go masters and mates, you will get it. If you go and get this read naval architecture, you also get a lot of questions and with solutions and all that, just to learn. So each and every topic, pick that book and read over, you will get more understanding. But if you only depend on these very things, there might be some questions that you might not be able to understand. So I'll urge all of you to go and read wide. When are you writing your exams? Next 2 weeks.
Yep.
Yes.
11th.
What dates?
11th.
On the 11th, right?
Yeah, we will start on the 11th.
No, but when are you writing the architecture?
Yeah.
Stop. What?
No, it's on the 19th.
On the 19th.
19th.
All right. Okay. So you have to prepare. All right. So this brings
So,
us. Okay.
I'm asking two questions rather. You spoke about right naval architecture. I don't know, along your thinking, something right. I think it's wheat. Okay, wheat. Yeah, you
No,
said
I say
wheat.
wheat never architecture. Yes.
Wheat.
Wheat. Yeah. REEDS.
Okay, REEDS. Okay,
Yes.
wheat
Yes.
architecture. Okay. And also the second question is what about we having a cylindrical shape, just like we have this rectangular sort of shape that we have every. What if it's in the case of a cylindrical type of tank? So how do we figure out that? How would you feel? How would
Okay.
you,
Even yes, some of them, like when you come here, okay, the question will come in a certain way that you will be able to calculate for the second moment of inertia, okay, second moment of area of the liquid or surface. Sometimes because the density of the liquid, you will always you will have it, okay. You will know it whether it's seawater or it's fresh water, or if it's using even if not that, it also specify the how do you call it, even not the density of the fluid liquid, they will even specify the other stuff for you to work that. Okay, so now if it's not a rectangle and cylindrical, question will be revolving around the second movement of what about the center line, and each and every cylindrical, how do you call it, object has its second movement of area about the center line. So then that becomes a way for you to go and search for cylindrical or the second movement of any cylindrical, how do you call it, this thing. But the question will state that, it will give you a clue about how you can use to calculate for that. Okay.
oh, sir.
Sir, so one more
Yeah.
thing. In the calculation, can you please go back to the screen? So we got the depth, the initial depth in the question as is 1.2,
Yeah.
right? And because it's half filled, that's why we use 0.6.
Yes.
Then okay, why did we divide this 0.6 by 2 again
Now,
when calculating for GG1?
Jane, okay. Now we want the center of what gravity within this very object. Okay, we want it center of gravity. You see, sometimes they are how do you call it, the assumptions. Okay, we come out with assumptions that okay, now we are presuming before this thing, we realize that this thing is very is straight. Okay, it's stable, so we are presuming that okay,
Yes, sir.
the whole thing will be stable when the center of gravity is in equilibrium with at the center line, okay, and it's at a point that it's keeping the whole thing in equilibrium. So then, okay, then we presume that half of this liquid here, okay, will be able to keep this very liquid at a stable at a stable condition or in equilibrium. Then we were able to divide this very 0.6 to 0.3 just to get a center of gravity. Then from there we can know that okay, this whole thing shape 2 has a center of gravity of 5.9. Okay, then if I know this, and then let me subtract and also know the center of gravity from here to what, to this side. So that is how come we have the 5.9 minus the 0.3. So as I've said earlier on, in fact, the naval architecture is something like intertwined. You move, you do this one, you don't forget it, but you carry it what? You carry it along. If, like for instance, you have forgotten this very formula, it means that you cannot solve. Is that not it? If you have forgotten this very one, you cannot solve. So there are a lot of things that you need to what, to understand. There are a lot of things you have to keep them also in mind. And now that you are doing online, it's not everything that you go and just pick and come and paste. Okay, you have to make sure that you understand all before you do it. So this ends what this ends the class. Okay. Any question? Sooner than that, I'll pose the quiz within 5 minutes time. Then all of you go and work it out. Okay. Okay.
Yes, sir.
Okay, sir.
Yes, sir.
All right. So we didn't.
So what time are we submitting it?
What time are you to close?
What time are we submitting it?
What time are you closing the class? 5 or
5. Yeah.
Okay, so by maybe
The class ends at 6.
6:30. 6:30 you
So the class ends at 6.
So from 5 to 7 we have math.
From 5 to 7.
We have math. 5.
5 to 7 we have
5 to
math.
7 you have maths.
Yes, sir.
Yes, sir.
So you have 1 hour 30 minutes now. Is that not it?
No, after this one you have math.
No, but we have 1 hour 30 minutes to close the class.
25
1 hour
minutes.
26 minutes.
1 hour 20 minutes.
And so use 1 hour.
25.
Yes. So submit the work at 8 o'clock.
8 o'clock.
8 o'clock.
Thank you, sir.
Yes.
What about those of us solving the first quiz?
And so no, that one I cannot give extra time. So the only thing I can do is submit it within a day. Not this very one. This very one, go with them. Okay? This very one, go with them. Submit this very work on the exact time. Okay? But I'm giving you the whole up to the end of the day, and the day ends at 12 o'clock. Is that not? So submit the work. Not this very one. This very one, if you submit it at 2 o'clock, it will even reject it. It will come as mixed, submitted late. So make sure you submit this very one by 8 o'clock. But the other one, make sure by the close of the day you submit that. Okay. All right. So within 5 minutes time, the question will be there. Then you solve.
Please. It's a problem in my class.
Okay.
BME 23. Someone can't join the class for now.
Why?
Someone into his account and then he changed the account's password, so he can't.
You can't join the class.
Yes.
Well, that one, if you can't join it, that one, I don't know what to do.
Of course.
That one,
Okay, sir.
yeah, because if you can't join, then how would he even submit? They do that, I cannot even submit. Is that not it?
Yes, sir.
And so
Yes, sir.
that one, I don't know what to.
Okay.
I don't know what to do.
Okay.
So just tell the person you should rectify that fast before it's too late.
All right, sir.
Okay.
Thank you.
Okay.
Charlie, attendance. Hey boy.
Please, I'm taking attendance. I'm not taking attendance.
Amen.
Why will you not do that?
Ah, boy.
Today, dear.
Why? Are you proposing to Vera in the Google classroom?
Yeah.
Vera, have a proposal.
Who is that? Yeah?
Vera,
It's who?